Hello and welcome to Algebra 2, Chapter 7.5, and today we're talking about graphing square root and cube root functions. So here is what we would call the parent graph of both of those functions. The first one is your square root function, the second one is your cube root. And what I want you to notice is that the parent function, so we haven't moved it anywhere, first of all, they both go through 0, 0. And they both go through 1, 1, and then your cube root also goes through -1, -1. And so if we base it off those 2 or 3 points, what we can do is we can take how a function moves or shifts and apply it to graphing other square root and cube root functions. Alright, so here's h and k again. We've had them before, and they tell you how a function moves. So h is going to be how it moves horizontally, and remember it is x minus h, so if it says x minus 2 it actually moves to the right 2, but if it says x plus 2 it's going to move to the left 2 because that minus is under there. And k is how it's going to move vertically. Okay? And then a is going to be how stretched it is. And so we might actually look, if we have an a value, we might look at that parent graph or that parent graph first and then move it. So first of all though, just what are these motions or what are these movements doing to the graph? So if we have y equals the cube root of x and we want to graph y equals the cube root of x minus 2 plus 1, how do we obtain that graph? And so the minus 2 underneath does what? That shifts it right 2. And then the plus 1 at the end shifts it up 1. Okay, so same transformations from graphing parabolas or graphing absolute value functions. Okay, so now this one, so I know I'm going to move left 4, down 1, but I have this 2 in the beginning, and so we need to consider that 2 first. So if we look at just the parent graph, if we look at that, so in square root you're going to look at 2 points, so we're going to look at 0 and 1 for x. So if we look at 0, we're going to get 0, okay? And if we look at 1, which before, remember, was 1, 1, if we look at 1, we're actually now going to get 2. So this one is going to be stretched up. In fact, it doubles. So if we go then, and we're going to move those 2 points, left 4, down 1. So each point, we're going to move left 4 and down 1. And then so before, and you don't have to draw it in, but that's what your graph would have been before. This right here is your graph that we're going for. So that blue one, you don't have to have that red one. Okay, so how does it change and then graph it? So the minus 3 shifts it right 3, because remember it's x minus, and the plus 2 shifts it up 2. But we got to start from these 2 basic points. And so if we are back to just y equals the square root of x, your 2 basic points are 0, 0, and 1, 1. Okay, so both of those points are going to shift right 3 and up 2. So those are my 2 new points, and then you just sketch your graph in there. Alright, so what happens if I have a cube root? Well, so first of all, I have this a value. So let's look at -2 cube root of x. And remember, we're looking at 3 points. And so for a cube root, our 3 points are -1, 0, and 1. So if you put in negative 1. Cube root of negative 1 is negative 1, so that's going to be 2. It's going to be 0, because cube root of 0 is 0. And this next one's going to be negative 2. So what this has actually done is, before your graph kind of looked like that, this is switching it. So negative 1 is going to be at a positive 2, and then 0, and then a negative 2. So if we were to draw this one in, it would look like that. Okay, but that is this parent function. So that's not the one I want to graph. I want to graph the one that's shifted right 3 up 2. So every point is going to go right 3 up 2. And then from there, we're going to come down this way and come up that way. So the red one is the graph of y equals negative 2 cube root of x minus 3 plus 2. Alright, so, and since on the last one we already figured out that our points are negative 1, 2, and then 0, and then 1, negative 2. So I've already figured that out. I'm going to shift my points right 1, up 1. So they're each going to go right 1, up 1, and those are going to be the points I use to sketch my graph. Alright, so the next thing that we're going to look at is the domain and the range of all of our examples. And so what I want you to do is I want you to go back and look at them. And I'm going to pull up our very last one here, is that we went right 1, up 1. Tell you what, we'll just look at an example here. So let's say that we have this cube root function. What is its domain and what is its range is the question. So remember that domain corresponds to your x values. And if I look at my x-axis here, is there any number on the x-axis that you would not have a corresponding point on the graph? There's not. You can pick any x you want, and there's a point on this graph someplace. So our domain is all real numbers. And for our range, we're going to look at our y-axis, and this, because this will gradually keep going up and down, so it's never going to just become horizontal. So are there any y values that are never going to be on our graph? There's not. So again, we're looking at all real numbers. Now, if you had a square root function, let's say that starts there at 1, the domain here is going to be x's that are greater than or equal to 1, because only those x's happen on this graph. And our range is going to be y's that are greater than or equal to 1, because only those y's happen on this graph. So it's not always all real numbers, so you need to make sure to look at your graph. Okay, so here we have the model for a period of a simple pendulum. T equals 2 pi times the square root of L over G, where L is the time in seconds, T is the time in seconds, L is the length of the pendulum in feet, and G is 32 feet per second squared, which is our gravity. So what you're going to do is you're going to use your graphing calculator to graph this model. And for those of you that don't have a graphing calculator at home, this is going to be something that if you have a problem like this that you're going to want to do in class. We will set it up now and then we'll graph it in class next time. So if we're looking at 2 pi square root of, we're going to call this x over 32, and so t is actually our y, and what you're going to do is you're going to graph that, and then you're going to estimate where you get, let's see, the period. So what is the y value when x is 3 feet? And so we're going to look at that graph. We'll look at that next time. And we have one other example here, and we'll have to look at this one in class too, because we need a graphing calculator for that. But if you want to plug that into your graphing calculator and see if you can find the weight of the whale, not the what, that is 60 feet long, and see if you can do that in your graphing calculator, and if not, we will discuss that in class next time. All right, so there's 7-5. Let me know if you have questions, and we'll see you in class.